Assalamu alaikum dear students. In the series of learning C programming, we are discussing dynamic memory allocation in C. In the previous video, we have discussed calloc function, malloc function and realloc function. Every single detail regarding these functions have been thoroughly discussed in previous videos. As I have already told you that all these three functions, that is calloc function, malloc function and realloc functions, are used to allocate the memory dynamically to the program. Now, we have left one more function, that is the pre-function. In today's video, we are going to discuss what is pre-function and what is the working of the pre-function, how the pre-function is used in the program, every minute single detail regarding this pre-function will be discussed in today's video very thoroughly with the help of the program. So, our today's video is pre-function. What is pre-function? First of all, this pre-function is used to deallocate the memory that have been allocated dynamically. That means we use this pre-function for deallocating the dynamic memory. Or we can say this pre-function is used to release the memory or to free the memory that have been previously allocated by using malloc, calloc or realloc function. So, as I have already told you that after using the memory, we must release that memory. We must free that memory. So, in order to free the dynamically allocated memory, we use this free function. Okay. Is the meaning of this free function. It is used for deallocating, it is used for releasing, or you can say it is used for freeing the memory that have been allocated by using malloc, calloc or realloc function. Second thing about this free function is that it is also defined in the header file, stdlib.h. As free function is also inbuilt function and it defined in the header file stdlib.h. Or we can say all these functions, all these dynamic memory allocation functions or deallocation functions such as calloc, malloc and realloc and this free function as well are defined in the header file stdlib.h. And this free function, the free function takes two arguments, one argument only. If we write the syntax, now we will write the syntax of this free function. Simply we can write syntax of this free function is general syntax, or we can say it is free and it takes only one argument. This free function takes only one argument, as malloc function takes only one argument, this calloc function takes two arguments, and realloc function also takes two arguments. But this free function takes only one argument, that is the pointer, PTR. Or you can say, or simple you can say pointer, previous pointer, and the return type of this free function is void. Always. This is general syntax of pre-function. First of all, pre-function is used to deallocate the memory that has been previously allocated dynamically by using the malloc, realloc or calloc function. Second one is this pre-function is defined in the header file stdlib.h, and the general syntax of pre-function is that simply we have to write a 3 and it takes one argument, that is a pointer. Though that pointer which had previously used for deallocating the memory. But when we use the dynamic memory allocation functions such as malloc, calloc or realloc, there it returns the address of the first block, and that address is going to be stored in the pointer. Here we have to write those pointers. That pointer takes this, has the argument of this free function. And the return type of pre-function is also always void. I hope now that you have understood now what is pre-function, where it is going to be defined, and what is the general syntax of the pre-function. For example, now we will try to understand the working of this pre-function with the help of examples. For example, previously PTR is a pointer and it is the integer PTR. I want to show integer here. For example, PTR is a pointer and I am requesting dynamically memory allocation by using the malloc function here, and malloc 2 into size of into that is it. What does this line do? This line will allocate the memory for two integers, for two elements of size integer. For example, and obviously the memory dynamically, the memory is going to be allocated from the heap portion. As I have already told you that the memory is, the layout of the memory is that some memory is reserved for the program text and the code, some is for the static and the dynamic, this static variables, or you can say global variables, and some portion of memory is for the stack and some portion of memory is for the heap. So dynamically the memory is going to be allocated from the heap portion of that memory. For example, and if suppose this is our heap portion, and by using this line, the 4, 1 and 2, for example, dynamic memory is allocated for two integers 1 and 2. That means total of 8 bytes of memory. Sorry, 4, yes, 8 bytes of memory will be allocated by the dynamically by using this malloc function here. And obviously it will return, for example, 2000 is the address of the first byte and 2004 will the address of the second. Obviously it will return the pointers of PTR address. Obviously now this PTR contains address of the first byte, or you can say base address of this memory block, and here it is 2000, that 2000 is going to be stored in this PTR. Now by using this PTR we can access these elements as well. For suppose the elements in our this malloc are 1 and 2. Okay, now for example, later on we are going to free this memory. For example, this memory has been allocated dynamically. Now if I write here free, what I have told you that this free function takes only one argument, that is the pointer. Which pointer? Where the address of the first byte, address of this previously allocated memory is stored. That is stored in this PTR. In this case, it will accept this argument PTR. And what does this learn? Simply, for example, here I will write this. This is PTR and it is pointing to this location 2000. Okay. When I use this function free, what will happen? It will deallocate, it will free this memory. This will get freed. That means I am going to free this PTR. That means now the PTR, this PTR does not point to this memory block. And now this memory block is referred back to the heap. Now it is going back to the heap where we have allocated. Now it is a part of that heap memory. So now this, by using this PTR, this function, deallocation function, now this heap, this memory is back to the heap. Now it is no longer there, this connected with this PTR. Now the question is, by using this function, whether the data which was present in the previously allocated memory also gets erased or also gets deleted, also gets freed or not? The categorical answer is no, because the pre is not responsible for deleting the data which was previously stored in the dynamic memory, which was previously stored in the memory that has previously allocated dynamically. Pre is not responsible for that. Pre is only responsible for this pre frees this pointer from this. It frees this pointer. Now this pointer is no longer pointing to this location, this memory block. That means here it is not. But take care. This PTR, if I try to write, this PTR still contains this 2000. But the 2000 is not pointing to anybody now. This is pointing to not pointing to anybody now. So we can say now the question is, can after freeing this memory by using this free function, can we later again access this data? That means, can we later dereference this pointer? For example, if later after freeing this I will write printf %d ptr 1. For example, this is the 0th and this is the 1. That means whether this will print this 2 or not. No. Because it will show me some undefined behavior. Because this PTR is not pointing to that location. It is now it acts as a dangling pointer. It acts as a node. So it is not allowed to use this indirection operator after freeing the pointer. We cannot dereference the pointer after freeing it. First, we have freed this PTR. Okay, that means now this PTR is not connected to the memory location which was previously allocated dynamically. Now this PTR is a dangling. It acts as a dangling pointer. We can say dangling pointer. And it is a possibility later this memory which I have freed by using this free function, it may be allocated to some other data. For example, if later I will write ptr next and malloc 3 into size of int. That means now here ptr. It is also a possibility that later here I have now requested for example, I have requested here the memory dynamic memory for 3 elements. That means 3 into 4 total of I have requested for 12 bytes of memory. It is possible that this memory will be later allocated because dynamically the memory is going to be allocated from the heap. When I freed this memory previously, it is now the part of the heap. It is possible that this along with this another byte will be allocated to me. It is possibility. Then if at that time I will access this value, for example, if I will access here printf %d pointer ptr 1, it is possible that it will return 1, and it is also possible that there will be some garbage value. We can also say that after freeing this memory, if I use this indirection operator, it will show us some undefined behavior. Either the program will get crashed, or it will show some undefined behavior. So it is not safe. We can say it is not safe to use this indirection operator or to dereference the pointer after freeing it. It is not possible. So it is not allowed. So now I hope that you have understood what is the working of the free. Simply the free function is used to deallocate the memory that you previously allocated by using the dynamic memory allocation functions such as malloc, calloc or alloc. And this pre function is defined in the header file stdlib.h. And the recurring type of the pre function is void, always void. And it takes only one argument, that is the previous pointer, which have been used while allocating the memory dynamically. So now it is best, for example, if I write a program, small program, void man, or you can say simply man, int, this is a pointer, ptr, and I want to, and number of elements from user, I, printf, and limit. That means first I am requesting the memory for dynamically, how many elements I want to store. For that I have to request the memory dynamically. Scanf %d address of, and ptr equal to int malloc and into size of int printf and elements for I equal to 0, I less than n, I plus plus. I plus plus scanf %d ptr plus I into size. ptr equal to null. That is it. Wait just a minute. I will bring the marker. Take care. I have stored three variables. I have because first one is a pointer ptr because I want to enter the integer elements. Then n is the number, how many elements I want to enter, and I is for the loop. Enter the limit, here n. N is, for example, I want 3 elements to enter. I want 3 elements. Obviously, this is a static memory allocation, it's not a dynamic. And obviously, the memory for these 3 variables are going to be allocated from the stack portion, which I have already told you. Now, enter the limit. Limit is 3. ptr. So, for example, this is our heap portion. This is a memory. And this is for code and text. Code and text. This is for global and static variables. And this is for stack, and this is for heap, for example, heap portion. This is the layout of the memory. ptr. Now, here, enter the limit. Here I have used this malloc function for allocating the memory dynamically for 3 integers. That means in this heap portion, about memory for 3 bytes, 3 into 4, that means 12 bytes of the memory will be allocated. Total 12 bytes of the memory will be allocated, where I have to store 3 integers. For example, here, here, and here. Enter the elements. Now I am going to enter the elements. Here I have used this for loop for entering the elements. which I have already discussed it in previous video. No need to discuss these things here. Secant percent D, PTR plus I into size. Obviously first this will get, for example, suppose the elements which I have entered are 1, 2 and 3. Now, after entering these elements, obviously it will return here, it is going to return this pointer PTR, and that will store, for example, 2000 is the address of this memory block, base address of this memory block, and it is going to be stored here, PTR. Now this PTR contains the address of the first block. Okay. And the memory for this, it is static because I have declared here, it is a static memory allocation, and memory for this PTR is going to be allocated from stack portion only. Because whenever we request for dynamic memory allocation, the memory is going to be allocated from the heap portion. For static variables or static functions, variables and functions, the memory is going to be allocated from this stack portion. Now, after using these, I have freed here, free PTR. That means this is going to be freed. Now, this PTR is no longer is connected to this memory block. And it has freed now, and it is again now, it is back to the heap portion. Now it is a part of the heap. Again, it has been deallocated now, and it is back to heap now. Now again it is heap, but the data is still existing there. 1, 2, 3. The data is still existing. Now we see here that this free function is not responsible for deleting the data which have been stored previously in a dynamic memory allocation. Dynamically memory allocation. Now it is not responsible. It is only responsible for deallocating. Only this connection is going to be kept. Now this PTR is not connecting to anybody here. It is not connected with this. It is now free. We can say PTR is now free. It is a free pointer. It's a dangling. It acts as a dangling pointer. If now after this, if I try, for example, now PTR contains 2000. Okay, PTR contains 2000. This memory is going to be free now, but it is still existing. It only frees. It is going to be freed only when after the exit of the program. Then the whole program is going to be executed, and after exit from this program, the static variables are going to be deleted, erased. The memory is going to be free. At this moment, it is still existing there, PTR. Now, here I have, but it continues. If I try to dereference it later, for example, if I here write printf %d and PTR1, for example, it is 0th location, it is the first one location and second location. Here I am going to access this location, address at this, but it will show me some undefined behavior because this PTR is no longer connected with this memory location. It's now free, it acts as a dangling pointer. It will show me some undefined behavior. So it is not allowed to dereference the pointer after freed them. Why? Whenever we have freed the pointer, after that it is not allowed to dereference that pointer. So it is if you use that, you can use it on your own risk and responsibility. Okay, so it is not allowed. Now, PTR contains still 200. It is best, it is good to reinitialize this pointer here, PTR equal to null, equal to null. And now this PTR contains null. So, after freeing the memory, after using this free the pointer, we should make it our habit to reinitialize that pointer with null in order to avoid some errors, in order to avoid this undefined behavior. For example, I have initialized this PTR with null. For example, I have PTR with null. And after that, I am again freeing PTR. It will again show me some error, double free error. It will show me some double free error or some other types of errors it will show. So now I hope that you have understood what is free function, what's the working of the free function, how the free function is going to be used in the program, and what will happen if we not free the, if we, for example, not free the function, what will happen? If we not free the function, still it will and will allocate memory later, and will use this dynamic memory allocation later again and again, and at some time this heap memory will get exhausted, and that is also dangerous. So we should make it our habit, after using this dynamic memory allocation memory, we must free that memory by using this free function. And with this lecture, we have completed the dynamic memory allocation concept. Now, inshallah, from the next video, we are going to discuss one more concept in C, that is the enumeration. That is enum data type. Till the next video, take care. Bye bye.